I think I will wait for 1 minute or so, see if more attendances show up.
So welcome everyone who already is in the meeting. As Christopher already mentioned, we will wait a minute or so everyone has time to sign up or to sign in, and then we kick off.
Okay, welcome everybody. I think it's time to start now because we have a limited time and it's really hard to tell you everything about the capital product in an hour. So I think it's good to start already. As I said, welcome to this webinar. I'm Christopher. I'm responsible for Siemens cabling and harness solutions for the small and medium businesses in the Nordics. I work with Innofor, and I will first have a little presentation about who Innofor is, and also tell you a little bit about capital and the capital suite which contains both capital and capital essentials. This first part of the webinar is focusing on capital essentials. Capital is the bigger brother of capital, but this will focus on capital essentials, who kind of is a little bit limited compared to capital. Of course, capital is the bigger brother, more focusing on the big companies, and capital essentials is more focusing on small and medium businesses. The big difference is that you have more features and you have more abilities and in capital compared to capital essentials. But the good thing is that you can start with capital essentials because it's particularly the same workflow and the same data. So you can start with capital essentials, and if you feel that you need more functionality, more features, and so on, you can go and buy capital instead. But I will start with introducing Innofor. Innofor is we are partners to Siemens. We are active in Benelux and Scandinavia. We have the headquarters in Almelo in the Netherlands. Innofor was started by 4 guys in Holland, and that's what you can hear in the name Innofor, 4 guys. And we also have a presentation in the Nordic countries. Like I said, I'm working with the cabling and harness solutions, but I have colleagues in the Nordic countries working with other softwares from Siemens. This is our website where you can read more about us and what we do and what we offer. And as I said, the headquarters is located in Almelo in the Netherlands. So what we will mostly talk about is capital essentials. At the end of the webinar, I will hand over to my colleague Filippo from Siemens, who will have a presentation about the hydraulics functionality in the capital suite. This hydraulic functionality requires that you have capital, though. So you don't have this functionality if you only have Capital Essentials. So Siemens is talking a lot about they call it digital twin. Everything you have in real life or as a hardware, you should have it presented in a digital environment as well. And that means that you should be able to automate more in the digital environment instead of automate or optimize everything at the hardware. And you should be able to simulate everything and verify everything in the digital environment instead of building prototypes and so on in the as a hardware. You should also be able to reuse your designs in an easy way, and you should have a traceability, and you should be able to repurposing. And what this mean if you have it the product in the digital environment, and this leads to fewer errors, less risk, which leads to lower costs and everything. We'll have better designs because you can do simulation and you can compare, you can work on different designs in parallel and compare the different designs which works best. This of course leads to lower development costs because you don't have to produce any hardware at the start of the projects. And you can really identify the issues with the design in an early stage. And it's also a fast-paced way to design because in the case of harnesses, for example, you don't have to build a number of prototype harnesses and try it in the real environment. You can do that digitally in the digital environment. And that means more innovation because it frees up time. And of course, this is really the future because traditional mechanical heavy designs is getting more electrical involved in their designs. So it's becoming a vast part of the products nowadays. This is really the three principles the capital workflow relies on. It should be data coherency. All instances in the process should share and use a common database. All the information and data should come from the same place. And also electromechanical co-op design this means that you can in parallel work with the mechanical department by sharing the same information during the process. You can start at the same time with the harnesses, at the same time you start with the mechanical design. And you can really verify that the harness have space allocated in the design, for example. So you can work in parallel. And also the digital environment allows you to automate certain tasks that you normally did manual. You can create a model to automate a large part of the design flow. So this is really the three environments you work with. On the left, you have the schematic part, where you, of course, do your schematic design. In the middle part, you can manage who should be able to edit the design and so on, and also have the MCAD environment. And on the right side, you have the harness part. This is really where you prepare the design for manufacturing, for production. So this is the data transfer between these three instances. Here on the left side, you have the schematic design, as I said. Here is where you create the wiring. You shows all the components and so on. This is where you can simulate certain parts of the design and compare it to, you can have in parallel working the different designs. And this is, you can already here start with synchronizing this to the MCAD environment. So you transfer the data to the MCAD environment. So, and also you can sync this to the harness design. So these three parts are really working in parallel. And on the right side, you have the harnesses. Here you can create form boards and you can engineer your harnesses and prepare it for production. You can have pictures added to the drawing, which shows you how to mount different components and so on. And you can generate different reports depending on what the supplier needs. So this is the workflow. This is really the most common way to start with the design. You start with adding devices and connectors. If you don't know the exact component you would like to add, but you know it's a device, you can just place a default device and decide later what kind of device. But the good thing is that you can really start with a rough estimate of how the design will look, and you can already here synchronize it through the 3D design. And here you also add wires, of course, and splices and cables. And I mean, while you're doing this design, you can perform a simulation of the design. You can see, for example, voltage drops, and you can see how the currency flows. If you have, in this case, you see that you have a couple of switches. You can see what happens if you toggle the switch in different positions. So then you can verify this design and go over to the right side. If you saw the earlier presentation, on the right side, you have the harness design. And then you go over to this part, and then you can continue with synchronize to the 3D design. You send the data from the harness design, and you can have the exact correct bundle sizes in 3D design, so you can see if there is enough space. And you can, for example, set a value of the maximum bend radius and so on. So you can exactly see how it will look like in real life in the 3D environment. You can, of course, add protections and so on in the 3D design and synchronize it back to the harness design, and it will show up on the 2D design. And you can here you can create the topology in the harness design by drawing the bundles, or you can do a flattening from the 3D design and place it in the 2D environment in Capital. And also here you have a verification stage where you have design rule check. which checks everything, that you have all the terminals in place and that everything is connected in a proper way. Otherwise, you can go through this DRC and it warns you. You can really go step by step and verify the design that you have everything. So it doesn't consist of errors and so on. And then you can prepare your form board review. Here they have added a few pictures how you should design or how you should you see a hand here how you should do things. You can import it to and place it on the form board design. So these are some examples of what data is transferred between these three boxes. So you transfer wires and cables and splices and connectors to the MCAD environment, and you update it in the MCAD environment, and then you send back and synchronize it back, and then you will have the correct lengths. And it's really exact lengths because it considers, for example, the travels within the connectors and so on. And the questions that could be answered is, will it fit in my vehicle in this case, or have I reserved enough space, and maybe have to modify some parts in the MCAD environment to be able to fit the harness within your product. And also are the bends in the harnesses possible? If it's too tight or something like that, you can't have this, you can only have a certain radius in the bends. And also you can transfer, you can place, for example, protections and tapes and so on in the 3D environment if you like, and transfer it to the form board design. Or you can place it in the form board design and transfer it back to the MCAD design. Yeah. I would also like to mention that we have also integration with the PLM, different PLM systems, the most common ones, and also, of course, the MCAD environment. So here we can handle the bill of materials, supplier relationship management, and all the documents and so on. So, like I mentioned in the start of the webinar here, there is two versions of Capital. And as I said, Capital is the bigger brother of Capital Essentials, but it's a good way to really start with Capital Essentials to really evaluate if this is something for you. You still have the integrations with the CAD environment, and the integrations, we have integrations with the most common MCAD tools. Yeah. So then I will start with a short demo. Like I said, it's really hard to show everything in because we have a limited time. But I will just show you a really simple how it works when you synchronize between, in this case, harness and schematic part. So here is start really with the schematic design, and this is the environment. When you start, I've already created a project. I call it Webinar January 2026, and then you will end up in this. This is how it looks. And here you have most functionality. You can hover over these buttons here. And then you can see a short video how you should work with these features. So you can hover over these buttons. And on the left side here, you have the design. Here you can see all the components you're using in your design. You also can start with symbols. Symbols are connected to the different components for the database, and the symbols is either generic or tied to the specific parts. I should say that the database you get with Capital Essentials, you have a default database, but you will also have access to this database online. So if you click this button here, you have this online database. It's constantly growing. And here you can actually download from many suppliers different components. And the good thing that is when you download this, you also will download for example, if you download a connector, you will also automatically download the compatible terminals to this connector, because you don't populate your connectors really in Capital. This is done automatically. So here you can download all kinds of different components that you can use in your design. And if you don't find it in your design, you can always create it from scratch in the database, of course. But I will start with a simple design. I know I have 3 devices in my design. I just create 3 devices. I don't know what the devices will be. Or maybe I know, in this case, I know that this should be an ECU. So I can search for it here. I know the name. So now it's an ECU. And if you click this button here, you can go to the database and show and see everything, every data from this particular component. You just fill in these tabs. For example, in this case, you have a footprint, you have a connector specified that is compatible with this. You should use this with this ECU. So if I choose this ECU here, now it's a real component here. And also if I want to create a connector, I can just click this button. Now it's specified in such a way that it knows exactly what connector is compatible with this ECU. I know for a fact that I will use four pins. So I will exclude power and ground here. I would place this in my design like this. And then I have the automate tab. Now I can generate the connector from this. So this will automatically create the connector compatible with this specific ECU. So if I double click on this, I can go and see what connector you have here. And I can also go into the database and look at the connector here. So I will continue with this device here. I know this is a sensor. I can either go and write it here, sensor, or I can go in and search for it. For example, yeah, sensor 0101. Then I will go and Place the pins. This is also specified in such a way that we have a connector compatible with it. I will use 2 pins, and I will automatically generate the connector. This design here, maybe I don't know yet which device I would like to use in this design here. So I can leave it as it is. I can still synchronize with the 3D design, and I can use this default device, and I can create a connector here. I know this connector will have 2 pins. Pin 1. And pin 2. And then it's time to wire this design up. I will add a multi-core from the library. Can either go and search for it here in the field here, or I can go and add restrictions and see if you're looking for something with a number of cavities or something like that. I can specify it here. In this case, I know exact multi-core. So then I have it in my tree over here. I can go and shows the address for the multi-core. Y1. Y2. You see a symbol here saying it's a multi-core. Now I will continue with routing a wire between these 2 devices. I will also here go into the database. Here I can filter. I know I would like to use a TVC wire. I can search for it. Oh. I can search for it here. Then it will show up all the TVC wires here, and I can, of course, nail it down to different colors and everything. So I will show 1.5 wire. Material TVC. Another 1.5. So now I've specified real components here. Not everything. This part I don't know yet, which connector on which device. But I will start with creating a harness now. And then I will save my design. And then I will mark all the components that are involved in my harness. So the connectors and the wires. And that will add a harness attribute. I will call this H1 harness 1. Oh. I have some technical issues with the keyboard right now. H1, there you go. And now it's time to go forward and create my harness design. So I will create a new harness design. I can name this design to H1 so it knows which harness that contains the data from the H1. But I can also name it H1. I also have to give it a unique part number. I can just type something 365. And then I will click OK. And this is, now I go over to harness design instead. Here I need to place the bundle, or I can have this topology from the 3D design. So I can do a flattening in the 3D design and place it on the 2D drawing. But now I know that since this is a simple harness, I know the bundles will go like this. So on this side, you have the ECU, and this side you have the sensor, and this side you have this device that I don't know exactly what to use. I have to, because if the connectors should end up in the correct places, where I will have to name the nodes in the harness design to P1, P102, P103, and then P104. I will name this to P102. P100. Something wrong with the keyboard. I'm really sorry. Now the nodes are the correct ones. So I will save this. This is my bundles. I will now go over to this and save this and close this schematic design. Now I will synchronize these designs. This is where the magic happens. Now I will have my harness on the harness part here. So you can see that you have the connectors here. You can see that you have a table over here with the components. I have the different wirings here. And this is where you can start to automate certain things, like you have this automate tab in the harness design. So here you can start with calculate multi-core lengths and so on, depending on which wirings you're using from the schematic design. Now it calculates the correct lengths. If you go into the bundle size here, you don't have a width yet. Then you can calculate the bundle sizes automatically. And then you have a width on the, and this, of course, you synchronize this to the 3D design, and it will show up in the 3D design. So the branches get bigger and takes more space in the 3D design. And you also have only specified the connectors. But like I told you, have, in these connectors, you have you have a certain terminals that are only compatible with this connector. So you can't choose the wrong terminals with the wrong connector. So that's this checks everything, and you can't choose the wrong wire size that is not compatible with the connector or the terminal. So that should be impossible. And then you can populate this terminal, and you press this button here, and it automatically shows us the right terminal for this connector. And you can also shows if you want it plugged or sealed and everything. Then it shows another terminal, but I will apply this. Now I did it for only this connector. I can apply it for all the cavity components. And you see the table was getting bigger now because you have the terminals now. You didn't have that before in the design. And of course, this was a real component, and this connector was a real component. But as you see, you haven't chosen the connector yet in the schematic design, but it shows the default symbol here. So you can still work with it and synchronize it to the 3D design if you haven't been able to choose the correct connector yet. So yeah, and also I should show you that you have this. Of course, this is kind of an immature design yet, but you have this check down here, and you can have it running in the background, the DRC, design rule check, and here, of course, this is an error, and you can, before you release it, this you can go step by step through all this and solve it, because it says, for example, cavity 3 has a blank terminal here, yeah, and you can click on this and you can fix it, and then you can go through the whole design and fix everything before you release it. I should also show you a little bit about, for example, styles. You can have different styles on the table. So if you choose the table here, you can have different styles, what data you would like to have in the table. And this also goes for styling. If you want a side view here, if you want the place it down below the connector or something, you can also fix this with styling and edit it like you want, and what data should be in the tables and so on. And also you can create different reports depending on what the supplier wants. You can create your own report, or you can choose already defined, or in this case, you would like to have a wire list, for example. And then you have the wire list that's there, and you can save it in different formats and so on, export it, and you can create the PDF and print it PDF. But you can also build your own reports if you want the specific information from there. So this was a short presentation of a really simple harness. And like I said, it's really hard to show you all the functionality in what is it, 40 minutes or so. So if it's needed, if you want to, I can create, or we can create a harness and create it from your harnesses that you are designing today. It's no problem. Now I will actually show you, because I haven't showed you yet, the integration with the MCAD. I will do this by showing a short video that shows the integration with the MCAD environment. I will start the video here. This means, of course, you can work simultaneously with the electric and MCAD guy can work together simultaneously in parallel. You can transfer the data back and forth. So here you export the data to the 3D environment, update the harness in the 3D environment. And then you update the 3D design and send it back to the capital again. So both guys have the latest data. So here you can transfer, for example, you will update the lengths back to the capital from the 3D design. Now do you have the new lengths? And here you do the flattening from the 3D design. You have routed all the bundles in the 3D design. You do a flattening of the bundles, and you can have this as a layout for your form board. And it's compatible, as you saw, with the NXCAT and SolidWorks and so on. Okay. So that's all I had. So I will hand over now to Filippo, who will show you a little about hydraulic functionality in Capital in this case.
Oh, thank you, Christopher. Okay, I'm going to share my screen, and please let me know when you see my screen. Okay, so good morning, everybody. Today I will talk about our solution for fluid design, and so basically, in particular, I will briefly introduce Capital, which is our main electrical engineering product, which is part of the Siemens accelerator environment, which is a portfolio where we offer solutions for multiple domains, like not only electrical, but mechanical, electronics, simulation, and et cetera, et cetera. So you have seen previously the Capital Essentials, and as Christopher said, Essential is just the light version of Capital, with the same interface, but with less functionality. So as part of the tool in Capital, I will provide just a short overview about fluid capabilities for creating hydraulic or pneumatic or P&ID schematics in conjunction with electrical schematics. So this solution offers a common and easy to use environment for fluid and electrical drawings by using an ISO 1219 or a P&ID symbol library, or you can create your own symbols yourself if you want. And we offer a configurable diagram look and feel to meet the specific ISO standards. Connectivity and 3D models can be linked, and this minimizes the data transfer errors across the two environments. ECAD, MCAD are integrated with PLM system, offering a full integrated solution. DRCs are used for design validation, and this will ensure that the data are correct by construction. Capital Logic Design is the product, so it's the name of the product, and which is the schematic entry tool for creating different. We see a different type of design. We call abstraction. So electrical and hydraulic are the drawings that we can create, and we have several capabilities for, of course, for electrical engineering. But just consider that an electrical schematic or an hydraulic schematic can be consuming by, for example, a service technician. And now let's see the tool in action. So I will run this small video demo, and what I will show you what you will see in this demo are different use cases. Not all, of course, because we have limited time. So the first one is just how to navigate across the different abstraction. So what you see here is an electrical wiring design with the full capability, so with the full icon on the ribbon. And then starting from this electro pump, which is a motor, we can navigate to the hydraulic design. And so we can jump from one design to another design. We see here the ribbon is limited, which is just only just to draw these different hydraulic schematic. But we can do the same if we go from the hydraulic to go into the wiring design instead. And here we see that we are coming back to where this component is placed in the wiring. The second use case is just, let's see very quickly how to create a simple schematic, okay? So we start first of all to create just the drawing. And when we create this drawing, we have the ability to define which kind of drawing we want to create, which abstraction, which is hydraulic. And when we select hydraulic, automatically the styling is selected. And the style set will drive you just, for example, to automatically place a border, but anytime you can change the border. And now you're ready to start placing your components in the drawing. And to place the component, you are going into the symbol library and search for your symbol by name, for example, or just scroll down the library and place the component. When you place the component, you can adjust the rotation. Yeah, okay, so and the position. And you can place, if you want, all components on the same on the same time. Okay, now let's wait for a moment. Alternatively, you can go in the library directly. And when we select a library part in the library, you have already part number associated to those components. And then you place in the similar way the graphic into the schematic. The next step will be now to connect with lines those components and easily, like Christopher did previously in Essentials, just to connect the components, okay, the pins in this very, very simple way. We have routing capability to automatically create and route the lines. Once this is done, then you will see at the end that we have also the ability to control the crossover shape, and then we can differentiate if we want a semicircle, a blank space, yeah, in this way, according some specific ISO standard, for example, or we can differentiate the distance on the blank space here. Next use case is about naming convention. So in Capital, we have naming convention capabilities. Automatically, the name are associated to any component, but you have a possibility to automate a name based on specific naming convention that you have in your organization or ISO standards, and we can generate names. And in this example, what you see is that, for example, for the valves, the name will start with the prefix QM plus a counter, which is automatically associated to the object based on a property. And the value of the property will drive the prefix. For example, for cylinder will be MM plus a counter, based on the fact that the property value it's a bit different. Alternatively, if you don't have, like in this case, no property associated to the component, you can pick the name from a predefined list that you have created previously, and you can choose the component by description, for example, or directly by the name, if that's the one that you want to use. And then you see that the short description is also associated to the component accordingly to the name. And just remember that the name must be unique, and the software ensure that that name is using when you run DRCs, for example. The table are updated accordingly with this information. Let's take a look on library association. So if we want to associate part number, because we need to create a bill of material, we can multi-select, in this case, lines. And then we can go to the library, to the database, so we can search for a specific part number. So for example, we want to associate a 10 millimeter hose to those line. Perfect. All right, then the BOM it's updated, and then maybe we want now to update the length of those lines, and you have two possibilities. You can do this manually. You can say, okay, I have maybe 250 millimeters of length for this hose, or you can use the 3D integration, the MCAD integration, and then the length will be automatically back annotated if you have a 3D integration. And then you see that the BOM table is now updated. Another use case is the way to control line type. So we can differentiate, for example, lines per color or per shape. Instead of continuous, we can have a different shape. And we can use this by using specific parameters, specific properties. And we can say, for example, that we have a primary circuit and secondary circuit that maybe will have different colors or different shape for the lines. In this example, just I used a different color for primary and secondary, and then when I apply the style set, the color will change automatically, and we will have green for primary and orange for secondary circuit. The next use case is about option management. So we have the ability to have a 150% schematic and manage configuration. And what we have to do it is just to assign an option code or create a Boolean expressions to the components, to the objects. So it's let's say it's very simple in that way to associate option code. And then what we can do is eventually to filter out the content, and we can filter per option, or we can filter per configuration if we have created a configuration, so a set of options. And then you see that all the parts of the circuit which is not part of this configuration will be hidden. The same if we select, for example, secondary, and then the primary part will go away, and then we see only the secondary configuration. Tables and reports. I think that we have already, let's say, talked about reports. So in Capital, we can visualize the table. The tables are automatically populated. And Christopher showed that we have the ability to create your own report if you want. Very, very simple. You can select which elements that you want to visualize in the table, for which components, for example, and where you want to consume that table. So in a drawing, or if you want, then eventually export the table outside the software, of course. And okay, of course, then we have to save. If you want instead, then visualize the report externally, so you can select a bill of material or a legend, and then that report can be saved in Excel and can be consumed externally, I don't know, for a supply or for something else. And the last use case, it's about simulation. So in this use case, you will see, for example, how we can control, or we can showcase the fluid circulation in a simple schematic. When we start analysis, here we have, for example, a couple of switches to control the valve coils, and the valve coil will drive, will activate the cylinders. So when we close, let's consider that we are going to close, for example, one of those button, the first one, the pull the pull button. And then we see that this will activate, the current will activate the coil on the right side. The flow will circulate in this direction, and then the movement of the cylinder will be in a pulling direction. And then in the opposite way, if we close the push button, this will activate the valve on the left side. The fluid will circulate on the opposite direction, and the movement of the cylinder will be pushing in that direction. So that's what we have in terms of analysis capabilities. And yes, this concludes my presentation and my demonstration. Okay, thank you, and over to you, Chris, Rick.
Thank you very much, Filippo. Of course, there are a lot of similarities. For example, what Filippo showed here was the simulation. This you can do in Capital Essentials as well, but not with hydraulics, of course, but electrics and all. The reports and everything that is included in Capital Essentials as well. But of course, the hydraulics functionality is only available together with Capital. So maybe we should go over to Rick now, because he has taken care of this. Is my colleague. He's sitting in Holland. I'm sitting in Jönköping in Sweden. And Rick is also working with the harness, cabling and harness. And he has taken care of some questions, hopefully.
Yeah, I mean, people can still submit questions via the Q&A window. I did got a question in, which is, so when we start, and I think Christopher sort of already handled that, because Filippo has shown something which is specifically in our Capital environment. And in the presentation that Christopher covered, he already mentioned that, well, we have actually two environments, Capital Essentials and Capital. And basically, people can move from Capital to Essentials to Capital if they, well, need more functionality. But one of the questions came in is how easy is that, and what do you need to do? Well, basically, both are using the same database, so they sort of have the same format of the database. You do need to export your designs out of Capital Essentials and bring them into Capital. That's definitely necessary, but the database format is exactly the same. And you will notice that also the look and feel is pretty much the same. So if you're working on a harness design, for example, in Capital, or you're working on a harness design in Capital Essentials, the look and feel is the same. What do you get extra when you move to Capital? Well, obviously, as Filippo already showed, the hydraulic possibilities, but also if you move more to the, I would say, to the production side, you do some cost optimization, you do some cost calculations. You would like to create what we call a structured bill of materials of each of the separate steps that are needed to create a wire harness, because your harness drawing is basically your guideline, or your guideline on how to produce the harness. And this is a step-by-step approach. You take a wire, you cut the wire, you put the terminals on, you put them into the connectors, and all these steps can be documented in a very, well, I would say, detailed way using Capital. Capital Essentials can be used to create those drawings, and if the drawings, the harness drawing, is enough to create your harness, then that's fine. But if the harnesses are more complex and they're going to be produced by, let's say, larger harness manufacturers that need a step-by-step approach, that is definitely where Capital takes a next step. So you will notice at a certain point that there are certain functions in Capital Essentials that are not there, that are there in Capital, but be aware that the work that you're doing in Capital Essentials is not lost. You can simply take that over and move up to Capital. That was basically the question that I have. It's a long answer on a short question, but at least it gives an impression of the two environments. We see Capital Essentials often for companies that start with initial, let's say, drawings of their wiring harness, their wiring diagrams, then their harness diagrams, and a lot of companies today use tools like Excel or Visuala or other tools to do this. And I think going to Capital Essentials is already quite a good step forward, because you can automate things. And as Christopher showed in his demo, it's rather easy to create a database of your components, your connectors that you're using, your wires, your terminals, and then have Capital Essentials or Capital automatically select the appropriate terminals for you based upon the connectors and the wires that you've selected in your design. You can simply draw a diagram as Christopher showed without having to care about those. And later on, when you're going to the harness diagram, then put in the, let's say, put the dots on the I's. So basically put the additional information in. So you can choose to simply start with I would say, a drawing of just a number of devices with connections in between and create a harness out of that. At some point, you need to start producing and you need to select components from your libraries. And you can do that at a wiring diagram, or you can do it in the harness diagram. I hope that sort of, well, gave an answer to a short question, but I don't know if there's any other questions, then please feel free to submit them in the Q&A window. If not, then I think we can close this this webinar. We're approximately on time, a little bit over, but I think that's okay. And we would like to, well, thank you all for attending. And please feel free to reach out to us if you have any following up questions. Please feel free to reach out to either one of us.
Yep. Yeah, please don't hesitate. We can come to your company and use your data and your harnesses to create a harness in the Capital environment for you. And we can
absolutely.
Yeah.
Absolutely.
So,
and also, Filippo, thank you for presenting the hydraulic part.
Thank you too, and thank you for your time, for everybody. And have a nice day.
Same to you. Bye-bye.
Same to you.
Bye.
Bye.